Hi, my name is Deval Deliwala, and here is an actual Tesla coil that I built over summer. I essentially started this project just because I was bored because of lockdown, but after 3.5 months of hard work, it actually ended up pretty well and outputted around 400,000 volts. You could have seen like arcs form around the breakout point and the discharge terminal, and it was just a pretty cool experience. So as you can see, there's a lot of different parts that make a Tesla coil. So I'm actually building it was also a really good experience, but yeah, if I go over all the parts real quick, you'll actually see how I actually built it. Alright, so for starters, I designed the Tesla coil on CAD before I built anything, just to get a sort of perception on the dimensions, the different parts I would do, how big it would be, all that different stuff. Then I started building. I started off with just retrieving the transformer, and then I built a spark gap, which is actually different than the final spark gap I did. It was much more complex, and it just ended not working for me. And then yeah, then I also built a capacitor bank. That was sort of the most difficult part to build because of all the different soldering you have to do. You have to add on the resistors to bleed out the capacitors once they were charged, and yeah, it was just very complex. Alright, then I had to build the primary coil, which is definitely not the hardest, but it took a while because there are many different steps to do before you can actually build a primary coil. You have to cut strips of high-density polyethylene in correct dimensions. You have to perfectly cut grooves into the high-density polyethylene so that a coil with the proper size could actually fit snug and wouldn't come out. And then once you did all that, I had to build the base. I had to drill the high-density polyethylene strips onto the base so that they were in place. And then finally, I could wind the coil onto the high-density polyethylene strips. And that even took a lot of time and a lot of different attempts because winding a perfect spiral by hand is very difficult. So yeah, as you can see, there were many different attempts that just didn't work out. But eventually I got it, yeah. Alright, so moving on to the secondary coil. This is by far the most annoying and tedious part of building a Tesla coil. You have to wind by hand 1,300 different coils of 26 gauge wire onto a PVC pipe, and it just took like a week because you can't do it for a while. But yeah, eventually I got it and it worked out pretty well. Alright, so now about the discharge terminal. It's the easiest part to build in Tesla coil, besides getting the transformer. I just got aluminum air duct, which is 4 inches in diameter, and aluminum duct tape. And then I just cut the required length off the aluminum air duct to fit snug inside of 2 aluminum pie dishes. And then I just taped different ends together and it formed a perfect toroid for what I needed. So after putting all these parts together, there were several other factors that needed to be taken care of. As you can see, I had many different stumbles. There were dust storms, so that kind of just destroyed the whole project and I had to restart. But yeah, eventually I got it, and eventually everything started to come together. I built a new spark gap, as you can see. It's just more simple, just 2 bolts, and there was a little arc that formed. Along with the capacitor bank, it shorted it and just produced a deafening sound that was actually pretty scary. And then even after all this, when I did my final tests, you could still see arcs form between the primary coil and the secondary coil, which was quite annoying because I was scared because I didn't know what to do to fix it. But then I just moved the tap, or the capacitor primary connection, a little bit further back, and that solved everything. And you could actually see quite a bit of arcs, and after a bit of tuning with the primary coil, I was able to achieve arcs that are around 5 inches long, which equates to nearly 400,000 volts of output.